Hello, I'm Maha from TE28 and this is my EMF3 assignment video. First, let me explain the Euler method. It helps to estimate the solution of a first-order ODE with a given initial value. Small steps referred as h are taken at equal intervals, using the green slope tangent to the curve at a point to find the next point that is close to the blue solution curve. For instance, a differential equation is given, dy dx equals to fxy. This signifies the green slope, where I will establish two coordinates, one where the slope is tangent to the curve and x1, y1. Right now, the coordinates x1 and y1 are unknown. Hence, I'll start finding x1 by referring to the graph I've drawn. x1 equals to x0 plus h, where h is the step size, whereas for y1, it is y0 plus the rise from y0 to y1. Over here, the rise from y0 to y1 equals to h times fxo It is derived from this equation, which is slope equals to rise over 1, with fxo signifying the slope. Now that the rise value has been obtained, y1 equals to y0 plus h times fxo. Simply repeat the same steps to find the next coordinates along the slope. Eventually, the general solution for Euler's method is yi plus 1, because the yi plus h times fxiyi. yi plus 1 signifies the next value of y, and yi and xi signifies the current values of y and x respectively. For the second part of this video, I'll now implement the Euler method in Excel. This is the IVP that is given, with the initial value of y equal to 1 when x equals to 0. Hence, I key in 0 and 1 under the first row of xi and yi plus 1 respectively. The step size h I'll use for now is 0.1. Under the third column, fxiyi is the value of IVP with the initial values of x and y substituted inside. Hence, I'll key in open bracket, d16 squared, close bracket plus 1, close bracket, divided by E16. D16 is the initial value of x, while E16 is the initial value of y. As for the values in the second row, xi equals to the previous values of xi plus step size. Hence, in Excel, I'll key in equals D16 plus $m $12. I must $m12 as the step size is a constant value. For the next value of yi plus 1, I'll key in equals E16, which is the previous value under yi plus 1, plus open bracket $m $12. The step size times f16 close bracket, which is the previous value under fxiyi. For the new value of fxiyi, just substitute the xi and yi values obtained in the same row of the table into the IVP. Since I already obtained the previous fxiyi value the same way, just drag the cell down. Do the same for the second row until xi equals to 1. Hence, through using the Euler's method, y when x equals to 1 is 1.91138. For the third part of this video, I will need to find the exact solution of the IVP using general solution, first order ODE. The first step is to group all y with dy on the left-hand side and x with dx on the right-hand side. Next, integrate both sides, label the equation as 1. Find a known constant c, substitute initial values, x equals to 0 and y equals to 1. Thus c equals to 1. Lastly, to find the exact value of y when x equals to 1, substitute c with 1 and x with 1 in equation 1 above. Finally, the exact solution of y when x equals to 1 is 1.91485. Comparing the exact value to the one obtained in Excel, I'll find the approximate error by subtracting the values found in the Euler's method from the exact solution, so I get 0.00347491. Here I repeated the Euler's method with a smaller step size h, which is 0.05, and got a smaller approximate value here. Error value here. Hence, this means that the accuracy of the Euler method depends on the step size, and that a smaller step size will result in more calculations needed to be done to find a more accurate approximate solution for the IVP. Thank you so much.